All right, so number 1, you had to find your second derivative, not just the derivative. So again, paying attention to directions, making sure you read them carefully. And number 3, let me tell you those answers because they're hard to see. All right, so number 3, the first answer, h prime of 1 was 2. H prime of 1 in part 2 was 3/8. H prime of 4 was -6. And H prime of 4 in part 4 was 1. Yes. Okay, looking down at trig derivatives, you have 4, 5, and 6. 7 is also trig derivative, but this time we are looking at the equation of a tangent line for the function. There you go. Yes. Sure. Sorry, you caught me right as I was drinking my coffee.
Like, I got the first one, but I don't know if you're getting the first one or the second.
And 6?
Yeah.
So just taking out a GCF. So like both terms contained cosecant 2x to the 5th, and both terms contained a 2x. I'll show you. Okay. So then next, and again, I'm going to go over them all at the end. So not ignoring your question, just going to kind of create a problem set to go over. Okay. Number 8 and 9. So again, we talked a lot about PVA, particle velocity and acceleration with movement along a line. So in number 8, you found your velocities and accelerations. And then you needed to find where it changed direction, which occurs when velocity is 0. And then we could find which direction it was moving by looking at the signs of the velocity. So it's moving to the left when velocity is negative. It's moving to the right when velocity is positive. And you could have extended that even further. You could have found when the accelerations were positive or negative, which in this case, since acceleration is 2, it's positive everywhere. Which means that when the object is moving left, the object is also slowing down. When the object is moving left, it is also slowing down because velocity would be negative and acceleration would be positive. Yes. No. If there were decimals, or it was trig functions, maybe. But, I mean, 11 halves isn't unreasonable. We don't need to graph this at all. What? But that's why, like, so that exact reason is why this is a non-calculator. Because the idea isn't being able to look at your graph and identify the regions of the graph. It's being able to, like, identify and read the equation itself and know, like, what it means without graphing it. Does that make sense? Like, I know what you're doing, but that's not kind of like what I'm assessing. And to be honest, it wouldn't be a calculator question on the AP exam. The AP exam in calculus is roughly 70% non-calculator and 30% calculator. If you are planning on attending PIT, and I only know PIT because I do the CHS program, their entire calculus 1 and 2 courses are non-calculator. You don't get a calculator for any of their calc math classes. If you were to have taken this class, CHS, every exam is non-calculator. So that's why I kind of try to take the focus off the calculators as much as possible. Because I don't know what the college or university you might consider going to is going to be. But I know there are some that don't allow them at all. Okay, so we have left 9 up there. 9 basically just said use the definition of the derivative. So again, make sure that if I ask you for the definition of the derivative, you're using the limit as h approaches 0. So number 9, you need to use the limit as h approaches 0 of f of x plus h minus f of x all over h. Yeah, I mean, I can't stop you from using the power rule to check it. But again, this would be a free response question where I'm looking for you plugging in and applying the definition. Okay, 10, 11, and 12. Yes. Yeah, I wouldn't actually have you FOIL the bottom. I don't like that the program did that. So personally, don't change any of your bottoms. Leave them as they were originally with the product foiled. Unfoiled, rather. Yeah, do not FOIL your denominators. Mm-hmm. Yeah, like they GCF'd the bottom. So like it's 30 originally, right? Like 3 times 10 is 30. But then if you square 2 times 2, you get 4x to the 10th. So they pulled out a 2. That's why I said, like, I know why they foiled their denominators, but that little bit of simplifying, you don't need to worry about. Yeah, I don't need that. I just, whenever I generate my questions, I can't change their answers. So I liked the program's questions, but I can't change the way the answer key's made. So you could totally have left it like that. That's why they also did it in like 13, so they could simplify. Okay, and then 14's a product rule and a chain rule. So some of us tend to forget to do both. We tend to take the derivative of the first, and then you take the derivative of the second. But you forget that the product rule says the first times derivative of the second plus the second times derivative of the first. So this is really, like I said, two parts. It's the first and the second. That is our product rule. And then you're adding a chain rule with that other piece. Okay, I don't know why 15 like goes way over there. For which one?
I don't know. My answers are just coming out very different. For 14.
Okay, so your 80 is okay. 80x cubed. 2x to the 5th minus 3.
Like, I think it's just my simplification. All of my first lines are the same.
They took out their GCFs, that's all. And then they simplify. So, like, this is a GCF with the second part. So that's why it's brought in front. And then they took pieces of this as a GCF.
Oh.
And then
10x to the 4th, 4x to the 4th, 3 to the 5th.
like I said, they just said, okay, 80 and 10 both divide by 10, so they brought out a 10. X cubed, x to the 4th, so they brought out x cubed. And then both terms contained 4 of these, so they brought that out in front. And then, like, what was left behind is here. This would leave behind an 8 and 2x to the 5th minus 3. And then that would leave behind an x and 4x to the 4th plus 3. So then they just distributed and combined like terms. Yeah. So 4 and 16 gave you 20, negative 24, positive 3. Sometimes the multiple choice answers on the AP test will get you down to that answer in 14. So that's part of the reason CUDA kind of does what they do sometimes. Usually the AP question will actually end right here with line 1. Because again, they're assessing, do you know the product rule? Do you know how to take first times root of the second plus second times root of the first and get all of your numbers correct?
So would it be okay with
Okay, and then 17 and 18, these are find the equation of a tangent line at the given point. So once again, you have to find your derivative. Oops, sorry. So the derivative of cosecant is, again, if you go back to our little trick, which my pen's not writing right now, we had the derivative of secant. There we go. Is secant tan, and the derivative of tan is secant squared. So like it went forward and backwards, and then it worked each way. Same with the cosecant. So the cosecant would become cosecant cotan, and derivative of cotan is cosecant cosecant. So in this case, it was negative cosecant, and then it should be, wow, I did it again. Cosecant 2x times cotan 2x. and it's negative because the derivative of any function that starts with c has a negative. But we're not done. You actually need to take the derivative of that angle. So this is multiplied by 2. Yes. Cosecant. Yeah. Cosecant's undefined at 0. Because cosecant's 1 over sine.
Sorry.
No, wait, now you're making me. Hold on, let me write it down. That's okay. Exactly, because once the cotan multiplied by 0, but if it was undefined and 0, the undefined overpowers the 0. Yes. So the answer would be yes if it was undefined at that point. Exactly. It would be, yes, it would be x equals instead of y equals. Ready? Do I still have it? I used to have my trig. I haven't been here for so long. She might have taken all the papers. So you should have, ready, here's your, we'll do this. We'll go on a little mini unit circle. Unit circle. So you can kind of see where we're at. All right. So in our problem, we were discussing, and where's my share your screen, new share, unit circle. Okay. So we have our unit circle values, right? So originally this starts at pi fourths. But because the angle in our problem is being altered, it's the cosecant of pi fourths times 2 that turns into pi halves. Cosecant is 1 over sine. So the sine at pi halves is 1. The sine at pi halves is 1. So that means that negative 2 times 1, because 1 over 1 is still 1, times cotangent. Well, cotangent is cosine over sine. So the cosine at pi halves is 0. The sine of pi halves is 1. So the cosine of pi halves is 0, which is how the slope at that point became 0. So if you go back to this, let's see if I can undo all my work that I erased. Probably not. But the idea is that this was y equals negative 2, cosecant 2x, cotangent 2x, and you got negative 2 times 1 times 0, which meant your slope was 0. If you have a slope of 0, then you end up with a horizontal line. And in this case, the horizontal line is at the y value from my point. Because it would be like y minus 1 equals 0, x minus pi fourths. So that all zeroes out, and then you add your 1 to the other side. Does that help? That's what I said. I was like, I think we just need to see the unit circle. So that, again, that's the problem, right? Our calculator, you're smarter than your calculator. If you do 1 over the tangent of something undefined, like 1 over something undefined, your calculator doesn't understand that the tangent is sine over cosine, which really it was cosine over sine. So if you're going to use your calculator, you need to turn tangents and cotangents to sines and cosines. That way you don't run into that error. But again, this would be a question that would be non-calculator. You would need to know your unit circle values on your own. Okay. Now I believe your packets had like a page beyond this page, right? Like I typed in my own pages that were attached to this. Yeah. So I have those and all of the work. I just have to find them now. So is one of yours about a ball being thrown into the air at height? Okay. I changed it. Alright. Here's the 2-4. I just threw all the papers at my house into this to come to school today. I think that was close. Alright, my camera's coming up. Okay. Okay. So one thing you'll notice is I really start to use brackets and the dots for my multiplication. I probably over dot them just because I like to show myself, like especially in here, like when I'm doing this times that plus that times that for the product rule. I like to put the dot so I remind myself where I am in that problem. It's not necessary, it's just something I like to do. Oh, it's really delayed from my hands to this. You're still checking? This? Yeah. From distributing this into the brackets. Oh, it's so delayed. So, like, the first line distributes inside to the brackets. Okay. All right. And then at the top of the next page, and then down at the bottom. You don't have to cancel them. They'll eventually cancel each other out anyways. It just makes your numbers easier to plug in. Like, even if you don't cancel them, you'd end up with, like, yeah, because either way they would simplify. Yeah, because -4 over 2 squared root of 2, -4 divided by 2 is still 2. Yeah, you're like back one line. Yeah, I know you did. I'm just saying, like, -4 over 2 squared root of 2 is still the same as -2 over negative square root of 2. -4 divided by 2 is 2. Like, you weren't wrong at that point. Yeah, that's what I said. Your bot, like, that was the error. The line before was not. Okay. So that kind of summarizes everything on our test. So again, we've discussed that the test is made up of multiple parts. Those parts consist of the following key ideas. So our key ideas are, do you know the definition of the derivative? Do you know the limit as h approaches 0 of f of x plus h minus f of x all over 0? Do you know the three laws of continuity and differentiability? So in order for a function to be continuous, f of a must exist. The limit as x approaches a of f of x must equal the limit as x approaches a from the left and the right. And then the limit must equal f of a. So again, coming off of that continuity, differentiability, in order to be differentiable, it cannot have a cusp. It cannot have a sharp curve. It cannot have a vertical tangent, and it cannot be discontinuous. So in order to be differentiable, it has to be continuous, and it has to be continuously smooth. It cannot have a cusp, corner, or vertical tangent. The intermediate value theorem is a direct continuation of continuity and differentiability. In order to apply IVT, a function must be both continuous and differentiable. And then IVT basically says, okay, here's x1, x2. Here are your y values at x1 and x2. Does a value exist between them? So is there a point on y that lives within the range from x1 to x2? And you use the idea of the y1 and y2 that match those x's to prove that. I will anticipate that you can find velocity and acceleration, that you understand particle motion in both the forward and backwards direction. You know when a particle is at rest. You can understand the difference between displacement and distance. And you know how to find speeding up or slowing down. You know your power, product, quotient, and chain rule. You understand trig derivatives and basic trig values at unit circles. And then you can also imply or find implicit differentiation problems. So again, our review changed a little bit. It used to be 3.1 to 3.6. Our group, we added 3.7, just where we were this year and the way the breaks fell. So I added implicit down here. Okay, going back to that first question that we had from the review packet. So we were discussing how to find and simplify this derivative. So again, this is a product rule. So our y prime is the first times derivative of the second plus the second times derivative of the first. So again, derivative of cosecant is negative cosecant 2x to the fifth cotan 2x to the fifth times the derivative of 2x to the fifth, which is 10x to the fourth. And then here's how we sort of simplify. First, we bring this out in front. And then over here, similarly, we're going to move the 10 and the negative. And then to get to this answer here, what they did was say, oh, this has a cosecant 2x to the 5th, and this has a cosecant 2x to the 5th. So let's take that out. Oh, you have 8 and x cubed, and I have negative 10 x to the 4th. So 8 and 10 both divide by 2. Both have x cubed. We're going to bring out that cosecant 2x to the 5th. And then what that leaves behind, well, here I took away x cubed. I divided 8 by 2 and got 4, and I took this away. So that's where the 4 came from. This is still negative. I divided 10 by 2 to get 5, but there's still an x there. And then you had 2x to the 4th minus 3, and a cotangent still. And then the final step was simply to take that negative 5, distribute it in here, and distribute the cotangent in there. So 5 times 2 is 10, x to the 5th, cotangent 2x to the 5th, minus a minus, so you get positive 15x cotan 2x to the 5th. In all honesty, even to stop here, in my opinion, is good. I think that's more helpful for plugging in values. It's going to give you smaller numbers. So like if it asks you to evaluate dy dx at a point, then that would be the best stopping point. To go down to this, it doesn't really help you. The whole point of simplifying is to find ways to help you. Ways to make things look better. So what I want to do is take a half an hour. I have one last review handout for you that is a derivative of a trig circuit. So again, it's one of the ones where it obviously has all the answers for you. If you want to use these 4 minutes and go take a break, or if you want to wait till halls are clear and take your break when no one's out there, go ahead and either go now for a little walk or wait till the second bell rings and take your walk after.